Hello and welcome to the last video of Math 092 and the last two sections of Chapter 6. We're going to take a look at some special types of factoring as well as a general rule for factoring. We're first going to start with what is called the difference of two squares. So we have here y squared minus 49. First thing we can notice here is that this is a difference. It's one term minus another term, and each term is a perfect square. Right, where I can take the square root of each term and get an exact answer. So the square root of y squared being y, the square root of 49 being 7. In our last video we learned how to factor something like this where we had a coefficient of 1. Here then we would be looking for factors of this last term, negative 49, that add up to our middle term. Now since we don't have a middle term, we can assume that the middle term is 0y. So having a coefficient of 0. We're then looking for factors of negative 49 that add up to 0. Those factors of course being 7 and negative 7. So using the rule from our last video, the way we would factor this would be, we would set up our two binomials. Our first term in each binomial would always just be y. And then our last term would be these two factors that we found, a positive 7 and a negative 7. Well, since this is a special type of factoring, we can notice here that for a difference of two squares, the first term in each binomial is the square root of our first term, and the square root of our second term is the last two terms in each binomial, one being positive and one being negative. This here is the product of a sum and difference, and we looked at in our last chapter how to multiply a sum and difference to get this binomial. Now we're just going backwards. We're factoring that product and getting back that sum and difference. So for a difference of two squares, our answer should always be a sum and difference. And our terms within them should be the square root of the first term and the square root of the second term, where the second term is negative, and so each term in my binomials has a different sign. Let's take a look at 4x squared minus 25. Here again, using that new rule, our first two terms should always be the square root of our first term, and our last two terms should be the square root of our last term. So in order for this to work, we have to notice first this is a difference of two squares. Our first term is a perfect square and our last term is a perfect square, and one term is positive and one term is negative. If it does not meet those conditions, then we cannot factor it this way. So to factor this, right, we do recognize that we do have a difference of two squares. So we take the square root of our first term, 2x, and 2x, and then the square root of our last term, 5, and 5. One is positive and one is negative. And that is our factorization. Let's try one more example. We'll do 100 minus 16x squared. Now again, we have to recognize, is this a difference of two squares? So it is a difference, and our first term is a perfect square, and our last term is a perfect square. So taking the square root of the first term gives me 10 and 10, and my last term 4x and 4x. One is positive and one is negative. So this then is my factorization. Things that I cannot factor this way would be like 9x squared plus 25. This is not a difference, even though each term is a perfect square. Right? Since they are being added together, I will not be able to have a positive and negative last term, which means I will not be able to cancel out my middle term when I multiply them together. So this cannot work. Also, if I had, say, 9x cubed minus 25, this also will not work since x cubed is not a perfect square. 5x squared minus 49. This also will not work since 5 here is not a perfect square. Or even x squared minus 52. Right here 52 is not a perfect square. So if I have any piece that is not a perfect square, or it is adding the two terms together rather than subtracting them, I will not be able to factor it using this method. One thing that I could factor, though, would be, say, 9x to the fourth minus 25. In something like this, right, x to the fourth is a perfect square, as x to the fourth can be written as x squared times x squared. So the square root of x to the fourth being x squared. So if I were to factor this difference of squares, I would have my first term as 3x squared and 3x squared. My last term being 5 and 5. One is positive and one is negative. And that then would be its factorization. Our next shortcut or trick will be from factoring a perfect square trinomial. So a perfect square trinomial comes in the form x squared plus 2xy plus y squared. Remember, this is the result from x plus y squared. So if we can recognize that we have a trinomial in this form, we will be able to factor it as a square binomial. So for example, if I have x squared plus 14x plus 49, this is a perfect square trinomial. The way I can recognize that is my first term is squared, my last term is squared. Both my first term and my last term are positive. They always have to be positive. And then my middle term is created from 2 times the square root of my first term times the square root of my last term. 2 times x times 7 gives me that middle term of 14x. So if my middle term fits that criteria, right, 2, always that factor of 2, times the square root of my first term and the square root of my last term, then it is a perfect square trinomial. So to factor something like this, right, I would know that I'm going to have a squared binomial. So I have a binomial squared. My first term is the square root of my first term, and my last term is the square root of my last term. And then my sign will always be the sign of my middle term. And that is the factorization of that trinomial. So x plus 7 squared. We can also factor this the way we learned in our last video, and just to verify that that is indeed true. So if we are factoring this using our old method of factoring, we would want to find factors of 49 that add up to our middle term. That would be 7 and 7, since 7 plus 7 adds up to 14. Then our two binomials, our first term would always just be x, and then our two terms would be the two factors we found, 7 and 7, and they are both positive. So we see here x plus 7 times x plus 7, which indeed is x plus 7 squared. Next, let's try 4x squared minus 4x plus 1. My first two terms are perfect squares. They are both positive. So now all I have to check is my middle term. My middle term should always be 2 times the square root of my first term. So square root of 4 is 2, square root of x squared is x. And the square root of my last term is 1. 2 times 2x times 1 gives me 4x. My middle term is a 4x. This sign in the middle, right, will only just tell me the sign in the middle of my binomial when I factor it. So even though I got a positive 4x and my middle term is a negative 4x, what I'm looking for is matching this part of the middle term. The sign does not matter. So if I go to factor this trinomial, right, I have a binomial squared, now that I have identified that it indeed is a perfect square trinomial. My first term will be the square root of my first term, 2x. And my second term will be the square root of my last term, 1. And then the sign is always the sign of my middle term. If I want to verify that this indeed is the correct factorization, I can multiply this binomial times itself. So to do that, I would rewrite this as 2x minus 1 times 2x minus 1, and then distribute. 2x times 2x gives me 4x squared. 2x times negative 1 gives me a negative 2x. Negative 1 times 2x gives me a negative 2x. Negative 1 times negative 1 gives me a positive 1. I add my two middle terms and I have 4x squared minus 4x plus 1. So I indeed get back what I started with. So that means that this then indeed is the correct factorization of that perfect square trinomial. We'll factor one more. We'll do 9y squared minus 30y plus 25. So we have to verify if this is a perfect square trinomial. The first term is a perfect square. The last term is a perfect square. They are both positive. My middle term should be 2 times the square root of my first term, 3y, times the square root of my last term, 5. So 2 times 3y times 5 gives me 30y. So indeed my middle term matches up, and this is a perfect square trinomial. My factorization then, I have a binomial squared. My first term is the square root of my first term in the trinomial, 3y. And my second term is the last term in the trinomial, 5. My sign is the sign for my middle term, minus. So I have 3y minus 5 squared as the factorization of my trinomial. These here are the rules of factoring. If we follow these steps, we can factor anything that we've looked at so far. So the first thing I always want to do is factor out the greatest common factor. So I look at all my terms and see if I can factor out a greatest common factor. The next thing I'll do is identify the number of terms in what I have left to factor. So if I have two terms, I check to see if it is a difference of squares. So it comes in the form of my first term squared minus my second term squared. To factor that, it's the square root of my first term plus the square root of my last term. One's positive, one's negative. If there are three terms, I have two options for three terms. If it does not have a coefficient in front of my x squared term, I assume a coefficient of 1, then all I have to do is find factors of c that add up to b, factors of my last term that add up to my middle term. Those then will be the last two terms in my two binomials. Then if I have three terms and I have a coefficient in front of my x squared, so something other than 1, I want to find factors of ac, right, multiplying a times c, so factors of that add up to my middle term. And then I factor by grouping. I split my middle term into those two new factors, and then group my first two terms and my last two terms and factor by grouping. If there are four terms, the only thing I can do is try factoring by grouping. If that doesn't work, if none of these work, then it cannot be factored. And remember, if it cannot be factored, it means that that polynomial is prime. And lastly, after I've followed those steps, I want to make sure that it is completely factored. If I have anything left that can still be factored again, I need to go through that steps for those remaining factors. So let's say I'm given something like 5x cubed minus 10x squared plus 15x. So before I totally panic, I go ahead and check out my rules of factoring. The first thing I want to do is factor out a greatest common factor. Well, I have a common factor of 5 for all my coefficients, and a common factor of x that I can also pull out. So I pull out that greatest common factor of 5x, which leaves me with x squared minus 2x plus 3. So now I have this trinomial left to factor. I identify the number of terms in that trinomial. There are 3. I check to see what type it is. It does not have a coefficient in front of my x squared, which means I need to find factors of c that add up to b. So factors of 3 that add up to a negative 2. So factors of 3 that add up to -2, we have a positive 3 and positive 1, or negative 3 and negative 1. If I add up these two terms, I get 4. If I add up these two terms, I get a -4. I don't have any other factors of positive 3, which means that this trinomial is prime. Therefore, this is the final factored form of my original trinomial. I want to double check here, check that it is completely factored. Right, 5x cannot be factored any further, and I checked this trinomial already and it could not be factored, so it is completely factored. Let's say I have 3x to the 4th minus 48x squared. Now at first glance I think, oh, this is a difference of squares, but 3 and 48 are not perfect squares. Before I jump to that conclusion, I need to remember, first thing I always do is factor out a greatest common factor. Here I have a common factor of 3 and x squared, so I can pull out my 3x squared, which leaves me with x squared minus 16. Now I'm factoring this binomial. It's got two terms, so I check to see if it is a difference of squares. Both terms are perfect squares, and it is a difference, so it is a difference of squares. So I keep my greatest common factor out front, and to factor my difference of squares, my first term is the square root of my first term, and my last term is the square root of my last term. For my signs then, I have plus and minus. I then need to check, is it completely factored? Right, 3x squared cannot be factored any further, x plus 4 cannot be factored, and neither can x minus 4. Now I could see here, oh, 4 is a perfect square, but x is not a perfect square. So this is not a difference of squares, so this is my final factored form. We'll take a look at an instance where it's not completely factored. Say for example we have x to the 4th minus 16. Here, these are both perfect squares. There is no greatest common factor, so I can go to my difference of squares. Right? My first term then is an x squared, and that's the square root of x to the 4th. My last term is a 4, and I have one positive, one negative. I need to check to see if it's completely factored. This here, right? These two terms are both perfect squares, but I have a plus sign in the middle, so it is not a difference of squares, so I cannot factor that. But over here, x squared minus 4, this is a difference of squares. Each term is a perfect square, and they're being subtracted. So I can factor this again. So I keep this first one that cannot be factored, x squared plus 4, and then I factor that remaining binomial. Right? My first term is the square root of that first term, x, and then my last term is the square root of my second term, and then I have one positive, one negative. Again, I'll check, is it completely factored? I know this can't be factored, x plus 2 cannot be factored, neither can x minus 2. So this then is my final factored form. Let's say I have 14x to the 4th plus 7x cubed minus 42x squared. And the first thing I always want to do is check, right, do I have a greatest common factor? Here I do have a greatest common factor of 7x squared. I factor that out and I'm left with 2x squared plus x minus 6. Now I'm factoring this trinomial. It's got 3 terms, and I do have a coefficient in front of my first term. So in order to factor that, I need to find factors of a times c that add up to my middle term. So that first term times my last term, 2 times a negative 6. So that gives me a negative 12. I'm looking for factors of negative 12 that add up to a positive 1. I have 4 and negative 3, 6 and negative 2, 12, negative 1. I check these here. I already do have my two factors. 4 times a negative 3 gives me my negative 12. they add together for a positive 1. So I use those two factors, these two here, to split my middle term and factor by grouping. So I bring down my greatest common factor, 7x squared, and then split that middle term. The first term stays the same, the last term stays the same, and the middle term gets split into a positive 4x and a negative 3x. So that 4x minus 3x gives me back that positive 1x. Now I group my first two terms and my last two terms, and always making sure to keep that negative sign with my 3. I'll put a little plus sign in between here to remind myself that I'm not multiplying those two now. And then I find a greatest common factor for those two terms. I have my 7x squared still out front. My greatest common factor of these two terms is 2x. So I have here 2x times what is left here of x plus 2. Then here, my greatest common factor, again I remember I want an x plus 2 to come out of here, so I need to factor out a negative 3, so that my first term in that binomial will be an x. So I'm factoring out a negative 3, which leaves me with x plus 2. Right, because again if I take out a negative 3 from negative 3x, it leaves me with x. Dividing out a negative 3 from a negative 6 gives me a positive 2. Now, I notice here that I have this same binomial in each of these two pieces, x plus 2 and x plus 2. So I will pull that out. Okay, again, remembering to keep my greatest common factor out front. Right, so now I have an x plus 2 that I've pulled out, and it's multiplied by what's left. If I pull an x plus 2 out of here, I'm left with 2x. Pull an x plus 2 out of here, I'm left with minus 3. So I check this to see if this is my final answer. Right, 7x squared cannot be factored any further. X plus 2 cannot be factored, and neither can 2x minus 3. So this is my final factored form. Alright, so we've seen things with 2 terms. Each of the 3 term possibilities, all that's left is one with 4 terms. So let's take a look at 15x cubed plus 10x squared minus 60x minus 40. Again, the first thing I look for is a greatest common factor. You notice that all of these terms have a common factor of 5. So I will pull out that common factor of 5, which leaves me with 3x cubed plus 2x squared minus 12x minus 8. Now I have 4 terms, so the only thing I can do with 4 terms is try to factor by grouping. So I will group my first 2 terms and my last 2 terms, remembering to put that little plus sign there. And then I look for greatest common factors, always keeping my 5 out front. So greatest common factor here is an x squared, which leaves me with 3x plus 2. Here my greatest common factor is a negative 4. So I have negative 4 that I pull out, leaving me with 3x plus 2. So now I can see I have that same binomial in each of those pieces. I pull that out, keep my 5 out front, and I have 3x plus 2 times what's left, my x squared minus 4. I check to see that it is completely factored. My 5 cannot be factored, it's just a term. 3x plus 2 cannot be factored. And x squared minus 4, well that looks familiar. It looks like a difference of squares. So I can factor that. I keep my 5 out front, my 3x plus 2, since neither of those can be factored, and factor that binomial, x squared minus 4. The square root of my first term is x, and the square root of my last term is 2. I have one positive, one negative, and hopefully this will be my complete factorization. I check, is it completely factored? Now, I know these first two cannot be factored any further, x plus 2 and x minus 2, neither of those can be factored. So this indeed is my complete factorization. That will do it for Chapter 6 and our last video for Math 092, so be sure to celebrate. Also, don't forget to take notes and prepare for our test next week. This week you will have lots of practice with your homework and quiz. Then next week don't forget to take the practice test before taking the actual Chapter 6 test. If you have any questions, feel free to ask me an email, and I will see you next week.